5 of the 10 largest floods in Earth history are from ice dam failures. So in this video, we are going to dive into the outburst flood phenomenon. A solid glacier or ice sheet can make a very good dam. When the water level rises high enough, it can actually float part of the glacier. A current then flows under the ice and quickly erodes a channel that allows the lake to rapidly drain, creating an outburst flood. But can this really explain the Missoula and Bonneville floods? Well, the largest of these to be observed was Catalina Lake in East Greenland, where almost a cubic mile of water was released. Lake Missoula held 500 cubic miles of water, and Lake Bonneville held 1,200 cubic miles. This is based upon the topography of the basins and the highest shorelines. I think that the outburst flood theory is definitely physically possible for both of these basins. But based upon the erosional evidence of the outflow, I don't think this is what happened. The flow trajectory doesn't match for Missoula, Bonneville, or Agassiz. Okay, so this is where Lake Bonneville was, and this right here is Red Rock Pass. So this is the valley that the lake drained from. This is the third largest flood in geologic history, and this is the erosion. You ready for it? It's catastrophic, you guys. Did that just blow your mind or what? This right here, this is fertile farmland, okay? You would expect this to be scablands, where it's just bedrock, eroded into gnarly shapes. Right here, we've got less topsoil, so it's a little bit more of a scabland. So we've got two riverbanks here of an expansion bar that was about 4 kilometers wide. These aren't even very large cliffs either. This is very mediocre stuff. Okay, so it just doesn't fit. The erosional evidence doesn't fit. I mean, we're talking about a 1,200 cubic mile lake draining through here in a catastrophic event. It would have so much inertia that it would carve a deep channel right here, and it would keep going into all this lava. It would have tore up the lava, and then it would have curved downstream and gone down the Snake River plain. But if we go up the channel a little ways, we can go over to a spot like this, and now we can find some pretty sick erosion. Right, so now we've got some drumlins. All right, these are features that take high-speed sheet water flow to form. So imagine sheet water flow just flowing down the Snake River Valley. You've also got ripples that form perpendicular. So you've got the drumlins that form parallel, and then you've got the ripples that line up perpendicular. So everything you'd expect from huge sheet water flow flowing down the Snake River Valley. Even though this is much more impressive, it has nothing to do with the catastrophic draining of Lake Bonneville.